Okay, now members, we are going to see a premium of a suspended lamina. Of course, we know what lamina is. This is a lamina. So we are going to see what happens in a premium of a suspended lamina. Here I'm having a triangle, but I'm going to use a rectangle so that you can see it also applies there. When a lamina is freely suspended, it rests when the line from the point of suspension through the center of gravity is vertically downwards. This is the case. Now, if this is before suspension, if I have this lamina, the rectangular triangular lamina, if I'm suspended from A, now the answer is going to rest when the line through the center of gravity resting vertically downwards. So this is before suspension, so I'm not suspended here. Then after releasing it, this is going to be the case. So the line from the point of suspension is going to pass it through the center of gravity. Note, this line from the point where we are going to suspend that lamina from. Of course, because this is the center of gravity, weight is going to act from there, and so here. Now, after suspending, of course, that is going to I've come with a simple example. You see, I want to suspend this from this point A. Okay? So I'm going to consider that this is now before I suspend it. You see, when I suspend it, you see that this line is going to pass through the point, and it's going to be a vertical line. I think you can see it's going to be vertical, as you can able see if I suspend it. So always the line from the point of suspension is going to pass through the center of gravity. Of course, this is the rectangle. Center of gravity is acting in the middle. From here is a half, and from here up there is a half. So I think you can see the case we are talking about. This is vertical. I think you see it's going to pass through the center of gravity, as you can able see there. Now, the line from the point of suspension through the center of gravity is always perpendicular to the horizontal. So you see, if after suspending it, of course this is vertical. It means that if this is bi-horizontal, you see those two are going to be perpendicular to each other. This part is used to find the angle the lamina makes it horizontal or vertical. How? If I have this case here, of course my center of gravity, if it's there. Now, because I know that when I suspend it, this is going to pass through the center of gravity line. This now I'm on this case before I suspend it. Of course, you don't need to draw a diagram to show that you are suspending it. No. You know that if this is the point of suspension, the line is going to pass it through from this to the center of gravity, and it's going to be perpendicular to the vertical line. So it means that now, after you making this line like this, of course, this is going to be the same. You see, when I put this back, I'm going to be having this shape. If I put this shape here. Now, this is going to be the line next to the vertical, and then this one can be alpha. It's going to be the line next to the horizontal. Where B is the center of gravity of that lamina. There. A is the point where the lamina is to be suspended. So this vertical line is from the point where it's suspended from, and the horizontal also passes through at that same point there. As I can able show you from here, I think you can able see that it's passing through that point. This is A. As you can see, passing through. This is now our horizontal, and this is going to be our vertical. As you can able see, they are perpendicular. I think you see they are perpendicular. Now, if I tilt it to this side backwards, that's what I have. So when they give you that one, you don't need to show how you are going to suspend. You just need to have the idea that the vertical line is going to be from A, where I'm suspending. It can be A, it can be B, it can be Q, it can be R, but it's from always A to the line, this one. Then, to the, of course, this is going to be our horizontal there. So this is the lamina, and this is now the vertical there, as you can clearly see. So don't be confused, this is the vertical, this is the lamina here. Okay. Consider, now if I consider this D here, ADD, that's triangle, and I put it here. This is our horizontal, this is our vertical. So if I put this the angle of theta, so this is going to be 90 from there. Of course, if if I call this now, this is going to be the lamina next with the horizontal. So this is the angle, this is the angle next with the vertical, where this is the vertical here. So from there now, it's that if this is 90 and this is the straight line, it means that when I add this and this, I get 90. So how do I get this theta? Because this is theta, you can use the opposite over adjacent, as simple as that. So when you know that idea, you see that here, I don't need to show the suspension. I know that always from A, the center of gravity, and then this is going to be the case horizontal is going to be perpendicular to that vertical. So as I'm showing you there. Let us go through a simple example here. The figure below has its center of gravity at a point 3, 4. If the figure is to be suspended in equilibrium from a point B, you note the point where they're suspending the lamina from now point B, comma, find the angle next to the horizontal and the vertical if the center of gravity was determined from AB and AE. So this one is having, it was, the center of gravity was determined from AE and AB. So those are helping us in terms when we are calculating here inside this. That's why I never calculated it, because it's not always true that it's going to be an X bar. This is not X bar, this is not X bar, this is not Y bar. Because it depends on which lines did you consider when you are getting that center of gravity. So this getting this one, of course, I read last time, this is 6 centimeters, and this one is going to be 8 centimeters. But our center of gravity, they are letting us it's C. So now this is where my D is going to be. So my D is here at a point 3, 4. But from which axis? From AB. Now, from AB, of course, now, because the one that's suspended from B, you see, to be suspended in equilibrium from B. So it means that now my vertical is going to be from here passing through that B. So if I am to draw this, the vertical is going to pass through the center of gravity. Now that is my vertical. So if this is my vertical, it's passing through the center of gravity there. So it means that now the horizontal, to be perpendicular, means that for it it's going to be like that. Sorry? In that order. Oh, iron N. So this is going to be my horizontal. And then the vertical is this one. This is going to be my vertical here. The vertical. The vertical is one from the point of suspension through the center of gravity. Now, if I call this theta, the lamina next to it, let me call it theta. It means that I can every get, because from here up here I know it's 9, so I can also call this alpha. Now, how do we get the distance? We know that where we are then determined, they tell us that from AE, it means that from here up to here, there are 3 units. So meaning, if I do this up to there, from AE, it means that this is the horizontal, of course X is the horizontal distance. So there are 3 centimeters. What about from AB? They're telling us there are 4. So meaning from here up to here, there are 4 centimeters. From AB, so meaning this is going to be 4, but this from here up to here is 3. So meaning if from here up to here is 8 and from here up to here is 3, the balance here, from here up to here, there are 3 centimeters. So the balance is going to be 5 centimeters up to there. So now, if I pull out that triangle, of course you can start from there. If you use this triangle here, now if I pick out this triangle, this is my theta, this one is 4 centimeters, and this is 5 centimeters. So you can able that. My tan theta is going to be the opposite over the adjacent. So my theta here is going to be 0.8 tan inverse. This is giving me 38.67 degrees. So this is the angle it makes with the vertical. With the vertical. So now we come and we get that one, it makes with the horizontal. Now this one is one that makes with the horizontal. So alpha plus theta is equal to 9. So our theta is going to be my alpha non theta. My alpha non theta. So this is my alpha now, because we have theta 0.33 degrees. So this is the angle now with the horizontal. So always don't get confused. Always from the point of suspension, this is what we call the vertical. Then this one is perpendicular. So what we call perpendicular to the vertical is the horizontal. So that is the case. Of course, I'm using this simple example. We are going to apply these ideas. Now, in the serious questions, you see determine the center of gravity and also get this. Of course, they can ask you one. They are not going to ask you both. They will ask you either horizontal or vertical. Simple. But the idea comes from here. I'm going to apply these tricks in the next example when the question is now full. See you there. Please don't forget to subscribe to the channel.